Welcome back, everyone. And so for the next 40 minutes, we'll be having a session celebrating the 25 years of CWC. And we'll be hearing from Martha. Martha Dennis, a very quick introduction. Many of you don't need introduction. Martha Dennis has been an entrepreneur, a technologist, very successful, in various different ways. But for us, most importantly, she has been one of the big supporters and proponents and steered through the formation of Center for Wireless Communication in its formation days. So I would like to invite Martha to take over and do this session, where we'll look back and look forward. Thank you, Martha. Martha, you're on mute. Okay, so maybe we can, as Martha is trying to reset her audio. Hi, Larry. There you go. Larry Milstein is not there, but maybe we can start the session with Dishon, you playing the video.
"2020 marked the 25th anniversary of CWC, the Center for Wireless Communications at UC San Diego. When it began, wireless was primarily second generation, or 2G, analog not digital, for voice, not data.
The mid-90s was an inflection point for communications technology worldwide.
Technologically speaking, that would land us somewhere between the old Stone Age and the Bronze Age. Wireless communications basically meant the ability to make a telephone call.
As time progressed, data started taking a large chunk of the total usage of wireless communication.
UC San Diego electrical engineering alumnus Kamal Sahota joined Qualcomm in 1993.
I was doing analog circuit design for CDMA phones.
Sahota later returned to campus to complete his master's in 1999 while still working at Qualcomm.
I was always interested in communications, and UCSD is one of the great schools, and we had a lot of great professors.
Another alumnus, Anton Monk, went on to finish his PhD in 1994 under Larry Milstein, founding director of the as-yet unnamed Wireless Center on campus.
My focus was on CDMA. You really couldn't build a modern communication system without having an understanding of spread spectrum and CDMA.
There were two revolutions, not one, but two.
Bob Kahn became dean of the School of Engineering in January 1994.
One was the internet, which is going to completely disrupt everything. We just didn't know quite how. And the second was the overtaking of landlines by wireless communications.
San Diego those days, was beginning to be known as the Wireless Valley.
Qualcomm was not yet 10 years old, but already a powerhouse. Kahn approached the company's co-founder and CEO, Irwin Jacobs, a former UC San Diego engineering professor.
I asked him to help bring to the school a group of all of the companies in the area that were interested in wireless communications. Well, I think more than 20 showed up, and I will say largely because of Irwin, but I would say also because they all knew they would need talent.
And that's where UC San Diego, with its history and its strengths in communications, came into play. There was a realization that if San Diego was going to be more than a location for one company that relied on government contracts, that you needed a larger ecosystem.
Looking back, getting CWC off the ground took nearly 2 years until 1995, when UC San Diego announced 7 founding industry partners, a dozen founding faculty, and its first permanent director, Anthony Akampora.
So it became apparent that the driving vision of the center would be one of wireless access to the internet. How we're going to break the umbilical and carry with us the equivalent of our laptop computer, except package it in something that was small, lightweight, didn't drain the battery too quickly, was capable of enormous bandwidth.
The Wireless Center at UCSD could really be a major driving intellectual force for wireless in San Diego.
By 1998, Larson was one of 10 new faculty recruits joining CWC for its first annual conference and research review. A year later, industry partners funded 7 projects leveraging matching funds from California's Communications Research Program.
The objective was to create a technological platform looking out 3 to 5 years that would provide fertile ground for industry to choose from when setting their own direction for product and service offerings.
The companies felt that they could harvest the value of the research, and we had a pretty good record of licensing our patents from CWC research.
Is because it's solely funded by our industry partners, we pay attention to what we can do together.
Importantly, CWC companies also gained access to great graduate students.
Every summer, for example, have a whole raft of students going off to various member companies. Many of them ended up having very good industry careers at those companies after they graduated.
Heading into a new decade, surging interest in wireless technology promised major advances. In 2000, CWC began hosting IEEE workshops, and the center attracted new industry affiliates, climbing to 17 member companies.
Everybody saw wireless as the future because the commercial application had just become well established.
Around this time, wireless companies were proliferating in San Diego. Case in point, Entropic Communications.
We started in 2001 and went public in 2007. I think it's one of the few fabless semiconductor companies in San Diego that actually went public.
Entropic co-founder Monk credits CWC's focus on communications and information theory as essential to San Diego's entrepreneurial wireless boom.
It's a huge help when it comes to launching companies in the wireless space. There's this direct link of using these foundational principles.
3G came and I think started really revolutionizing how we think of wireless.
CWC was a critical factor when UC San Diego competed with other UC campuses for a $100 million award from the state of California for Advanced Research Institutes.
The Center for Wireless Communication was absolutely central to winning, period. It influenced the choice of what topic area the campus would choose. And we chose telecommunications and information technology.
Then CWC Director Ramesh Rao, who became director of the UC San Diego division of the California Institute for Telecommunications and Information Technology in 2001, says CWC's experience with companies gave the campus an edge.
We weren't starting from standstill. Having done the Center for Wireless Communications and having watched its growth, we knew how to work with an industry consortium.
In 2002, Ericsson and UC greenlit new projects on adaptive and CDMA systems, while Intel and HP sponsored work on ultra-wideband wireless. The following year, Peter Asbeck occupied the first of 5 new endowed chairs in wireless funded by CWC partners. In addition to Asbeck's chair funded by Skyworks, a spin-off of Connexent, Qualcomm chairs went to Ramesh Rao and Ilan Orlitsky, and Ericsson chairs to Bhaskar Rao and Larry Milstein. In 2005, CWC researchers achieved a world record efficiency above 50% for high-power cellular base station amplifiers. A year later, CWC renewed its focus on MIMO antenna systems, coding for wireless networks, and more. By the time Pamela Cosman took over as CWC director in 2006, several wireless companies were downsizing in San Diego and elsewhere.
There were certainly some companies which were reducing their presence in San Diego at that time. And also student enrollments were down, I think from about 2006 to 2009.
So things were a little slower. That was a challenge.
As 3.5G arrived, CWC's Gabriel Rebez unveiled the world's most complex silicon phased array chip. And in 2008, CWC's Rene Cruz, co-founder of Mushroom Networks, accepted Connect's Most Innovative New Product Award in wireless. Both Mushroom Networks and Ortiva Wireless, the latter co-founded by CWC's Sujit Day, were among the first startups to be based on center research. CWC faculty and students presented 19 papers at 2009's RFIC and International Microwave Symposium. Many of CWC's former student researchers played key roles in 4G and then 5G innovations.
So I think we've trained probably thousands of students who are now in senior leadership position in the wireless industry, making a phenomenal impact.
CWC's Rebez shared in the IEEE Krauss Antenna Award for his work on antennas and imaging arrays for millimeter wave and terahertz applications, and the following year, he and Tower Jazz demoed the first wafer-scale phased array with 16 different antenna elements operating at 110 gigahertz. And CWC opened its first 5G forum on next-generation wireless systems and applications. The following year, Sujit Day succeeded Orlitsky as director and expanded the center's focus on wireless applications.
From 2015 onwards, we oriented ourselves not just doing fundamental research, which we are always excellent in doing, but asking the hard questions, and that's harder work.
I think it helps to connect to particular applications such as healthcare and the environment.
Also in 2015, member company Keysight and Rebez demoed a phased array transmitter that proved 5G capable of delivering record performance. 3 years later, CWC stepped up its focus on 5G-enabled applications in connected health and smart transportation.
We have widened our tent in doing that. We have been able to recruit companies that otherwise would not have joined CWC.
5G has enabled a whole new set of potential markets and verticals.
One of the most promising things that I pick up on 5G is this ultra-low latency that allows millisecond latency guarantees, so remote surgery or mission-critical things like autonomous driving.
The Internet of Things is one of the applications that people have in mind for very low power because they're envisioning lots and lots of devices in very close proximity to one another.
As commercial 5G began rolling out in 2019, CWC researchers were devising new approaches to the Internet of Things. And in 2020, they built new apps for contact tracing and for COVID-positive patients not requiring hospitalization.
In rolling out our COVID-19 platform in clinics in San Diego, I was surprised as how many people today, even today, do not have cell phones, do not have digital technologies. And so my worry is that as we roll out 5G, that it might create more digital divide.
Every major problem that mankind faces, I think, working with pandemics, working with food shortages, I think we have to figure out how to do that by taking advantage of this technology.
CWC expects that all of its constituencies, students, faculty, industry, can benefit from its current strategic direction.
Our industry partners can benefit tremendously because these students will not only be strong in terms of theoretical understanding and knowledge.
New technology is also bound to impact how and where CWC and the wireless industry go between now and the expected arrival of 6G in 2030.
Satellite delivery of wireless services, internet in particular, is starting to become more practical again. So that's a real game changer for the wireless industry.
Maybe 10 years from now, when we look back, we should be more data-driven. It's time for machine learning to help wireless communications out.
Meantime, CWC is growing and continues to play a key role in the Jacobs School with active support from current Dean Al Pisano in what is now ranked one of the top 10 graduate engineering schools in the nation.
It has continued to be relevant. It has continued to bond faculty, students, and postdocs together with research staff. It's basically a bedrock element of the strength of the School of Engineering to this day.
That's a trajectory that I think will be very, very exciting in this next 10 years and will have huge impact, health impact, economic impact, research impact.
And that impact should help CWC and its member companies as they embark on the center's next 25 years of research, education, and wireless innovation.
Can you hear me?
Yes.
Oh, hooray. I had to use my cell phone, unfortunately. I don't know what's wrong with my computer. However, welcome to the 25th anniversary celebration of the UC Center for Wireless, UC San Diego Center for Wireless Communications. As I was introduced, I am a co-founder of Pacific Communication Sciences Incorporated, one of the charter member companies of the center. I represented PCSI on the founding board, where we created one of the first education industry partnerships in the University of California. It was a thrill 25 years ago, and it's still as exciting today. And that the wireless industry is participating in such a significant way with the university to help commercialize the future of wireless. As of today, 41 companies have participated as members of the center. Quite an impressive record. We created this video, and I was not planning to have seen it when it was shown just now, but it is a really stellar representation of all those years. And now I'd like to introduce the directors of the center in chronological order. And I've asked each director to make some very brief comments addressing what changed in wireless during their tenure as directors, and then where they predict the wireless field would advance from here in the next 25 years. So I'd like to start out with Larry Milstein. Larry, are you there?
Unmute, Larry.
Can you hear me now?
Yes.
Oh, very good. Okay, so there are two parts to Martha's question. The first one regarding what happened during the time duration that I was the founding director. So the center, we started working the center in 93. It opened up in 95, about a year and a half later. When it first started in 93, voice was by far and away the dominant application. A year and a half later, voice was still the dominant, but at that point, it was quite clear that data was becoming more and more popular, more and more heavily used. Regarding the future, I'm going to try and do this incrementally and start by calling right now T equals 0 the starting point, and that the state of the art is 5G. And from my perspective, which is physical layer comm, 5G can be summarized in two words: millimeter wave and massive MIMO. Now, to jump from that point to 10 years later, okay, I'm picking 10 years because the generations of wireless improvements and advances have been in increments of about 10 years. And so that would put us 10 years from today to be at 6G with the same status of 6G then is what 5G is today. And what is that? Well, in some sense, it's very similar to 5G because they're still looking at going up to higher frequency bands to get more bandwidth, except instead of going in the millimeter range, they're talking about going into the terahertz range. And similarly, the use of MIMO extensively to have very efficient bandwidth, to have very strong bandwidth efficiency is also will be a part of 5G. There's also different things about 5G that do not exist there are other advances that will be in 6G that did not exist in 5G. Among the key ones might be the merging of the drone industry and the cellular communications industry. The point is that the key reason here is that to go a step beyond that, to go beyond 10 years out, you're now talking about beyond 6G, which is pretty tricky to get any information about. but I was able to track down some of it. And while they're still thinking about staying out in the same frequency band, terahertz band, the most of what they're talking about in terms of their key technologies will not, in my opinion, be communications. Okay? My prediction rather is that rather than being communications, it will be in the areas of quantum computing, artificial electronics, and various other computer science-oriented areas, such as, for example, data analytics. So that's my prediction. Maybe they'll take us to 20 years out. I can't make it to 25 years out.
Thank you so much. Well, somebody else will take it on after that, I'm sure. So next we have Tony Akampura, who was the next director.
Thanks, Martha. So I'm going to turn my time machine back 25 years, back in 1995. And as was already said several times, back then, cellular communications basically meant cellular telephony, cell phones communicating with cell towers. We didn't even have Wi-Fi. So when you left your home, you took your cell phone with you, you put it in your pocket, and you can make telephone calls. What you couldn't do is send and receive email. You couldn't browse the internet, upload photos. You couldn't download audio. There was a lot that was lacking. Despite the fact that you can do all of these things from your home or your office using then available wireline technology, DSL or cable modem, or just the Ethernet. So it became apparent that the Wireless Center would be focusing on wireless access to the internet. And we developed a program recognizing that we've got some serious constraints: small devices, lightweight, power constrained, bandwidth constrained, needing to operate in a very hostile wireless communications environment with shadow fading and multipath fading, which by themselves would limit bandwidth if the FCC didn't already limit bandwidth. So our program involved systems, communication theory, information theory, image communications. Our program involved circuits, power amplifiers, high-speed digital electronics, and our program included networking, media access techniques, cell handoff techniques, and finally, we had a strong element of software as well. Back then, it wasn't quite apparent where the dividing line would be, how much intelligence would reside behind the cell tower, and how much would actually be in the cell phone. So we had a pretty sizable effort on that. So moving ahead 5 years to address Martha's question, by 1999, we were into 3G. We had CDMA. We had reasonably high quality data communications. We certainly had the foundations for what would become 4G. We knew about OFDM. We knew about smart antennas. We knew a lot about MIMO. And sure enough, over time, these technologies evolved into the network that is serving us now. Now, you ask, looking into the future, what would we expect? And this reminds me of my early days at Bell Labs in basic research, where our saying very often was identifying the frontier. How could we take all of our knowledge and apply it in a non-incremental fashion, not more of just adding to what the knowledge base we already have and putting in more antennas as an example, or going to higher order modulation, but what are the true frontiers? Where can we really apply our talent to achieve a scientific followed by a commercial breakthrough? Orders of magnitude, not incremental. And I'm going to leave it at that. That's what the Wireless Center, in my opinion, needs to be pondering. That's 90% of the problem.
Thank you. That was wonderful. The old days. Next, we have Ramesh Rao. Ramesh, can you pick up?
Yes, thank you, Martha. It's can't resist this opportunity to go down the memory lane, and I was looking around, and I dug up my first cell phone, the Sprint Pioneer program I enrolled in back in '97, The battery life was 4 hours, but I don't think I ever got more than 50 minutes on one charge. The standby time was 2 days. But the funniest story I want to share with you from back in the day when Sprint PCS brought CDMA to San Diego. We had been talking about it for a couple of years at the center, but the service became available in 1997. My story is about handoff. We were researching things like paging networks and so on. But I was driving up in Orange County one day and wanted to make a call to my wife. And because the origination and the destination of the phone were in two different counties, that connection wasn't going to be made without human intervention. So an operator came on the phone and asked me to pronounce my name by way of verification. So I said, Ramesh Rao. And the guy, young man, said, that's not right. You're not going to be able to put this call through for you. I said, what's wrong? He said, that's not the way to pronounce your name. So I made a fuss, and we further escalated that handoff to his supervisor. And the supervisor was very polite, but she said, the only way I can put it through is if you will share your federal tax ID with me.
Oh.
So it was 50 cents a minute back then, airtime. And when you were calling across county lines, I think it went up, and they wanted to make sure that this was not a fraudulent call. But rather than share with you, so a lot has changed since then. We now call across the planet at no cost. Rather than share with you the whole story of what we have all witnessed, I wanted to mention that the thing that caught my attention back then was energy efficiency. We figured that battery life was going to remain a critical part of the capabilities that these systems offered to end users. And we started looking at that problem in a little bit more detail. And I think concretely, thanks to the Wireless Center and its members, we came to the realization that assumptions you make, resource allocation assumptions you make that are optimized for voice, which was predominantly what everybody was doing, may not be the right thing if you're trying to transmit data. So for example, if your channel fades because you're going through a tunnel and you have packet loss, it would be the wrong thing to try to retransmit repeatedly while you're inside a tunnel. You're using up your finite battery capacity and you're not going to get through. So learning to understand the demand, the channel impairments and the quality of service connections was an interesting problem. And we got some fascinating results that connected protocols like TCP that had been developed for the wireline environment, how to adapt it for the wireless environment, which was something that came up much later. As I reflect on it today, I feel this business of stochastic energy supply and stochastic energy demand has actually broadened. It's not just a problem that cell phones have to cope with, but if you look at renewable energy on the grid, that's basically what we are dealing with. How do you do this scheduling so that you can match the supply to the demand? But battery lives, I think, remains a critical problem to this day because all these advanced technologies like MIMO and so on lay heavy claim on processing. And so some of the early problems that we identified, while they have evolved in terms of how they get exploited, I think the core problems have remained.
Thank you so much. Next, we have Larry Larson from the East Coast.
Hi, everyone. It's really great to see you all. And as I was listening to these stories, traveling down memory lane, I do have a brief personal story that I thought I would interject, which shows how far we've truly come over the last decades. And I grew up in the Washington, D.C. area in the 1970s. And my father worked for the government at the time. And one morning, a really high official, like someone who's very high up in the administration, drove up our driveway because he wanted to meet with my father. He drove up in one of these big black government limousines, which were very common at the time. And my father talked to this guy for a while. And then my father gestured me over to the car, and they opened the trunk of the car. And in the back of this car, the car was full of electronics in the back. Imagine a big, Lincoln Continental with full of electronics. And my father said, Larry, you won't believe this, but there's a phone in the back of this car. and the person who's driving this car can make a telephone call from anywhere in the Washington, D.C. area. And it just completely blew my mind that it was possible to have a telephone in a car. So we've come an awfully long way in the last 45 years. During my time as director, we were sort of in the middle of 3G technology, and 4G technology was on the way. This was an era when, Motorola, Ericsson, Nokia, and BlackBerry were dominating the industry, and we thought they would be dominating the industry forever. Smartphones had not taken off yet, as we all know. That was a big 2007 was a big event in this industry. Millimeter wave technology and MIMO, which Larry Milstein talked about, were still kind of gleams in our eyes. Wi-Fi was just starting to take off then. 802.11b was coming up, but 802.11a had not really taken off yet. And I think that the term Wi-Fi came out about 2005. I think at the time we all felt that wireless technology was just miraculous stuff, but we had no idea how miraculous it was really going to become in the next, 15 or 20 years. And Martha, you also asked about 25 years looking forward. I think that, the demand for bits is essentially infinite in this world, and it's just going to continue to keep going up. And we're just going to be pushing more and more bits to people around the world and into devices for the foreseeable future. I see two big kind of global developments, and these are from a hardware perspective. One is, I think Moore's law is beginning to level off, and how we continue to make dramatic progress in wireless communications if Moore's law is slowing down is a real challenge for the industry. I know that chip companies all over the world are struggling with this right now. I think the other thing that's quite exciting is, satellite delivery of the internet on a global broad basis has been tried and failed, many, many times. But there are some new developments in that area, and who knows, that may actually become a really viable technology in the time ahead. So those are two things I'm watching that I'm very excited about.
Thank you so much. Next, we have Pam Cosden.
Yeah, I was CWC director from 2006 to 2008, and those were incredibly consequential years for wireless and for technology in general. Of course, the biggest thing was in January 2007 when the iPhone was unveiled. Steve Jobs called it a magical product, and most people agreed. And then just 10 months later, the open source Android platform was announced, and that was another remarkable development. Those particular years also saw the launches of Amazon Kindle and Twitter, and the point when, for the first time, people were sending more texts than making phone calls. Also, Facebook broke out of universities and went global. GPS arrived in mobile phones. Google bought YouTube, and Netflix, of course, launched its streaming service. You probably all remember those red envelopes that used to arrive in the mail, and sometimes the DVD was scratched. So even in the context of 25 exciting years for wireless, 2006 to 2008 was really a legendary 24 months, both in terms of physical technology and applications. As far as predictions for the future, if I could first answer, where did I predict back then that things were going? Well, with everything on a skyrocketing trajectory in those years, it really seemed like everyone's wildest ideas were about to be realized. And we shouldn't forget that the Marvel Cinematic Universe began in 2008 with Iron Man. So we all expected that we'd have the holographic Jarvis AI and personal drone fleets and so forth, and probably a colony on Mars. And then, of course, the world economic system came crashing down with the recession of 2008, which was not caused by overexcitement in the tech sector, but rather by the more prosaic housing loan industry. But as for the future looking forward at this point, I'm still holding out, Martha, for that mind-controlled personal AI assistant and my own fleet of drones.
Well, I hope you get there. Thank you. And Rao Bhaskar.
Well, you need to unmute.
I started at UCSD, but did no wireless research at that time. So my initial years were more signal processing and phased arrays and so on. So when the wireless center started, I remember going to the meeting that Tony Akampura had called to brainstorm about new projects. Okay. So I was sitting in the room and people went to the board and Tony was writing on the board several projects. And the meeting was coming to an end and I realized that none of those projects I could participate. Okay. So I said, okay, how about MIMO? I had heard about MIMO and I used the word MIMO at that time. And Tony was, of course, very excited. He said, yeah, of course, we should be doing MIMO. So there came the fifth project, which is MIMO. Okay? Then he said, oh, you should lead it. I had not planned to actually lead anything on an area that I had no idea about. But little did I know, but then there were several faculty who wanted to participate in the project. And so there I got started in wireless communication. Okay? And of course, I still am doing massive MIMO. Okay, and it's been a great 16 or 20 years. Now I served as the director from 2008 to 2011. So that was the economic crisis. So a little challenging, in terms of funding and so on. Okay. So I remember every time going into the office wondering who would call. Okay, and then of course the transition from 3G to 5G, 4G, and as Pam pointed out, the iPhone had taken hold. So it was actually quite, I think, a consolidation phase. I think people were wondering what's next in wireless communication. Okay? So I'm really glad that Sujit took over and started the next phase. Okay? But it's nevertheless a very interesting period in the wireless space. Now, in terms of looking 25 years into the future, okay, I wear glasses with power close to 7, so my vision is pretty blurred. Okay, so I will say this is my vision expectation, is that the improvements in wireless and related technologies will continue to improve unabated. Okay, I don't see the big jumps that people are talking about. I think it's what Larry Milstein talked about, newer, more and more massive MIMO maybe. But I do hope these technologies improve so that I can enjoy my golden years, okay? Living in a connected world with significantly richer experiences at all levels. Okay? So I could go have entertainment at a different level, social interactions, health, and live a fulfilling life. Okay?
Thank you. I think your vision is better than ours, in fact. So let me finish up with 2 minutes of Sujit, who is, I think Alon did not make it. Alon Orlitsky did not make it, but please give us your 2 minutes, Sujit, and then I'll finish up.
It's just been amazing hearing from all of you guys. I still remember when I first, one of the reasons I joined UCSD, besides my other offers, is because my dream of, or my excitement about wireless, I didn't know much about wireless. I used to work at NEC Research, where some other folks used to do wireless. I used to do system on chips. But that's why I wanted to come here. And I'm glad I came to UCSD, and glad that, we had all of you as directors. Been really exciting several years. So when I took over in early 2015 January, I think, as Bhaskar said, the last few years have been tough for not just the wireless industry, for wireless research, for wireless in general. It was a little directionless. Maybe there was also a sense that we have had enough. We have pretty much fulfilled what we had to do. I remember having attended meetings like that. On the other hand, the great thing was, and this is something that Alon put his finger right on, and that is 5G is really starting to happen. And so that was really a lifeline for the entire industry, for all the university research and so on. And rightfully so, because 5G was significantly different than 4G. Not only in terms of the network, the core architecture, all those things, of course, but significantly different, I think, in terms of mindset. And, as an entrepreneur before that, having started Ortiva Wireless, selling wireless video gateways to various network operators, you would constantly get this pushback that it's all about bits and bytes. So what you can enable, so much, nice video going through my network, but it's all about bits and bytes. It's all about pricing is bits, right? And that mindset moved, 5G moved that mindset. And I think we recognize that. And we recognize that the monetization, the economy, of 5G or whatever G comes, will not be based on, selling volume and selling bits. And that propelled us to look at, okay, so what is the impact going to be of 5G? What are the applications that will be enabled? What are the use cases, which can be monetized by even operators that can be. And so we started to really robust programs, connected health and smart transportation. Happy for that. Looking forward, one of the things that I've always believed in is that 5 years, 10 years from now, what will become commonplace technology or service is already cooking. There's nothing that is not cooking now that will be rolled out 5 years from now, right? So on the other hand, if you take a long-term look, I am pretty sure of two things, I think. One is that we will not have these mobile devices like this. Yes, we will have some, but there'll be so much more. I'm looking forward to the day where we'll be able to work on virtual spaces. We'll be able to gesture, we'll be able to write, we'll be able to communicate with each other, cooperate with each other across the world on virtual spaces. And so that's one of the technologies, one of the breakthroughs I'm looking forward to. And the other is, all of you remember the modem dialing days, right? You have to dial the modem and it will make that noise. You have to get access to that, 9 kilobits per second kind of network, right? From that, and as Pam, you mentioned, what a revolution when Apple was announced. And even before that, actually, with BlackBerry and so on. But devices which became always on, right? I didn't have to get access to the network. I get to my device and the device has the network. But from that, I look forward to the day where we can have our own network, own personal network. I could have called it a computer, but this network will have resources. Yes, computing resources, intelligence resources, but also sensing resources. This is my network, my private virtualized network, where I can, use resources as far away as 10K miles maybe. And so this will be our own personal networks. Now, our own doesn't mean that consumer, yes, consumer, but also small businesses, big businesses. These networks will be living with us, will be guiding us, will be recommending to us, taking care of our business decisions. And yes, we'll have avatars, and maybe I belong to multiple networks akin to social networks, but these are cyber physical networks. But there'll be avatars representing us and doing various transactions on behalf of us, and essentially enabling us to get the right resources for our right needs, be they social needs, professional needs, and so on. So that's kind of the dream that I have in the future. We'll see. Thanks.
Thank you. So I want to thank all of you for your wonderful observations and all your predictions, and I hope they will all come true. And of course, for your leadership as directors, as well as outstanding academics and researchers. The wireless industry is incredibly grateful for the existence of the Center for Wireless Communications, its creativity, its expertise, and the ability, more than anything, to collaborate so effectively with the industry. So keep up the tradition, and we're expecting many, many more things to come from you. And with that, I am now going to give the virtual podium to Sujit, who will recognize the past directors and ask them to open their gifts that they have received ahead of time. And I can't wait to see what it is. So, Sujit.
Thanks a lot, Martha. Thanks for your, all your work in helping create this center, which has lived very well for 25 years. Thanks, Martha, to you. And yes, if you can open the gifts. Thanks again. Thanks again for all of your services.
Thank you. Thank you very, very much.
It would have been an amazing thing if we could have got together, but maybe we'll, do it next year, hopefully. Thanks again.
Okay, thank you.
Thanks, Martha.
Thanks for, talk to you later.
Thank you, Sujit and Martha. Bye-bye.
Thanks, Larry.
Bye.